Hi, fourth grade, and welcome back to Math with Mr. G. Today we're going to be continuing our work for week 4. Today's day 2. And we're going to be working more and more on our factors, prime and composite numbers, and our multiples, just like we were yesterday. So let's review some of our rules. So factors are the numbers you multiply to get another number. So for instance, 2 times 3 gives us 6, as well as 1 times 6 gives us 6. So in this case, the factors of 6 are 1, 2, 3, and 6. So again, the things you multiply to find the product of 6, or the factors of 6. Let's look at prime numbers. So prime numbers are the numbers that only have 2 factors, only 2. And they're 1 and themselves. So for instance, for 19, only 1 and 19 can go into 19. There's no other number that you can multiply, or combination of numbers you can multiply to give yourself 19. Let's look at composite numbers. So composite numbers are the numbers that have more than 2 factors. So they can be multiplied by more than just themselves and 1 to end up with that product or factor of that number. So for instance, 10, I can multiply 1 times 10 to get 10. I can also multiply 2 times 5 to get 10. So the factors of 10 are 1, 2, 5, and 10. So there's 4 factors that are making it composite. And finding multiples, you'll see later on, is just seeing, using those number trees and seeing the different layers, the different rings that you have, and how many of those things are multiples. We're going to be adding just a new component to that today as well, and practicing more with that. So let's look at finding some factors here. So I'm going to use my strategy, my factor rainbow, which I'm a big fan of. I find it very useful. So I have 1 and 25. That was the worst written 25 ever. Here we go, let's try this again. 25, so 1 to 25. Now let's see what we can multiply to find 25 in between. Well, there's only 2 other numbers that can be, well, 1 other number really that can be multiplied to give you this, and that's 5 in itself. So what numbers can be multiplied into 25? Well, 1, 5, and 25. So you can see there's more than just itself. 25 is just barely composite. Let's look at 27. So we have 1 and 27. I know I can't multiply 2 by anything to get 27 because 27 is odd, but 3 can go into 27 and it goes into it 9 times. Like so. So what are my factors of 27? 1, 3, 9, and 27. And this is a composite number. Okay, let's scroll down some and find the factors of 12. So I'm going to try and give myself some space here for my rainbow. So 1 and 12, like so. Let's look at 2. 2 can be multiplied by 6 to get 12. I can also multiply 3 and 4. And there's no other numbers in between, so this is my complete rainbow. So I have 1, 2, 3, 4, 6, and 12. There's a lot of factors that go into 12, so this is composite. Great. Let's move down to this. So we're going to be finding some multiples first of 3 and 4. So I'm actually going to build myself a number tree for 3 and a number tree for 4. And it looks like I'm going up 1, 2, 3, 4, 5, 6, 7, 8, 9 rings for 3. So I'm going to start way up here so I have room. Of course, if you can skip count by 3, you can fill this in, but I'm going to use this tree method as a good method for this. So I have 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 21, 24, 27. All right, so we needed 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9 rings. Perfect. Now let's do it for 4 as well. I'm going to do it right next to it. Okay. So I have to do 1, 2, 3, 4, 5, 6, 7 of these. So I have 4, 8, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Okay. So let's fill in all these multiples before we go any farther. For all my multiples are 3, I have 3, 6, 9, 12, 15, 18, 21, 24, and 27. All the multiples of 4 that we have written are 4, 8, 12, 16, 20, 24, 28. Great. So we need to find common multiples. And what common means is they share them in common. They both have them. So let's look through our number trees here. Oh, so I see there's actually 12 here and 24. So on this number of rings that we have for both 3 and 4, we have 2 common multiples, which are 12 and 24. Now the next one, the LCM. So LCM stands for least common multiple. And it doesn't mean that it's less likely, it means it's the smallest. Least isn't smallest common multiple. So the smallest of these is 12. 12 is the least common multiple of 3 and 4. So it's the number that they share in common. That's the smallest. It's the least. Let's look at some more factoring to build into prime or composite. So list all the factors for the number 16. If you guessed it, we are in fact going to do a rainbow. So 1, 16. And then we also have 4 and 4. So all the factors of 16 are 1, 4, and 16. 16 is in fact a composite number. So let's look down here. So this one's asking us, this is from our assessment from today, it says which numbers are prime. So here is a really useful trick for you guys, okay? Even numbers, with the exception of 2, are always composite. That's because 2 can go into them every time. Not just 1 in itself, but 2 can go into even numbers anytime. So any number that ends in an even number, 2, 4, 6, 8, or 10, doesn't matter how big it is, it's a composite number. So 16 is even, and 6 is even. So that narrows this down a lot for us. It's taken 2 out of 5 of those right out of the running. So let's look at the other ones. I have 11. Well, let's do a factor rainbow for 11. 1 and 11. 2 can't go into it, neither can 3, 4, 5, or 6. So 11 is prime. I'll put a P next to it so I know it works. Let's do 23. It's not even, so 2 can't go into it, neither can 3 or 4 or 5, 6, 7, or 8. So 23 is prime. Let's try 17. Nope, 2, 3, 4, 5, 6, none of those numbers can go in, so our prime numbers are 11, 23, and 17. So A is our answer for this one. As we continue our work with this, tomorrow we're going to be looking again at all of this over again and practicing and looking over our different strategies and how they combine together and can be interlaid with each other like this. If you need help or review for these, please rewatch this video as well as yesterday's. And you can always come back to this video at any later point and find it again. As always, I look forward to your work, and I'll see you guys tomorrow.